Similarly, if two vectors are anti-parallel to each other, and again suppose the magnitude of both the vectors are the same. Now the sum of these two vectors, again we'll use the same formula for the sum of these two vectors, and we have to note that the angle between the vector is 180 degree. So the resultant vector will be equal to a square plus 2ab cos theta plus b square. Now cos 180 degree happens to be -1. So this whole thing would be 0. Which should have been the case. So if two vectors are opposite in direction, we simply subtract them as we do with normal numbers. Okay? Okay. Now suppose we have two vectors like this. Suppose this is 3, this is 4. The magnitude of the vectors are 3 and 4. The length should be proportional to magnitude. Now, what would be their resultant, the magnitude of the resultant vector? This is the formula for the magnitude of the resultant vector, and now you should be acquainted enough with this formula so that you can solve easy problems like this orally. Now here the theta is 90 degree, cos 90 degree is 0, so the middle term would be 0. So you only have a square plus b square. So you have a simple formula like this. Resultant vector would be equal to a square plus b square. In this case, the resultant vector would be 5. And the angle of the resultant vector, let's see. The angle of the resultant vector, if the angle we are looking from a vector, then that is b sine theta upon a plus b cos theta. The angle, if we are looking from the vector whose magnitude is 3, then the tan phi will be equal to 4 sine theta upon 3 plus 4 cos theta. This is how you will use the formula. Theta here is the angle between both the vectors. Angle here is 90 degrees, sine 90 degree is 1. So this turns out to be 4 cos 90 degree is 0, 4 by 3. So the angle which the vector is making, which is phi, is tan inverse 4 by 3. Now this is how we write. Tan theta is equal to 4 by 3, then theta is equal to tan inverse 4 by 3. Now this is not a standard angle, so you may not know what this theta is, but at least you'll be able to represent that theta is tan inverse 4 by 3. Okay, this is just the representation. The trigonometry you will later study what is tan inverse 4 by 3, or there's a whole chapter on inverse trigonometry in which this inverse functions you'll be studying, tan inverse, sine inverse, cos inverse. But for now, if tan theta is 4 by 3, we can write theta as tan inverse 4 by 3. It's a representation for now. Okay. Similarly, now we'll solve it orally. Okay. If two vectors have been given like this. Suppose the value, let's take as 10 and 10, and this angle is given as 120 degree. Now the formula, now if I say that, if I use this formula directly, a square plus 2ab plus b square, 2ab cos theta plus b square, and if I take theta here as 120 degree and I put theta as 120, then cos 120 is minus half. So that makes it this minus half, this minus sign comes here, half and 2, they cancel out. So it basically becomes a squared minus a squared plus a squared, because a and b are same here. So minus a squared and minus a squared cancels out, so it becomes a squared. Root over a squared, that is a. The answer would be 10. But that would be egregiously wrong, because the angle between these two vectors is not 120 degree, because we have learned to see the angle between two vectors. We have to put them tail to tail or head to head, not head to tail. So the angle, if I extend this vector like this, then this is actually the angle when we put them tail to tail. When we do that, I'm sorry, when we do that, the angle will turn out to be 60 degree. Now when we put theta as 60 degree, cos 60 degree is half and 2. So it is a squared plus a squared plus a squared, root over 3a squared. So that is root over 3a. Root over 3, 10, or 10 root 3. So this is the right answer. So basically you have to be cautious. You don't have, when you put theta here, theta is actually the angle between the vector and not just any other angle. Okay? Okay. Now that was the addition of vector. Now let's move on.